So my topic today is called AWS Infrastructure by Design, a practical decision framework. And it has evolved from my initial suggestion, which was just with a focus on backend patterns. I thought, why not make it a more comprehensive decision framework that we all can use in the modern agile teams, right? Okay, so about myself, just a little bit. I'm from Kazakhstan. I moved to UK a couple of years ago. And now I'm working as a tech lead at Tech Ltd. It's a digital agency company. We are building many apps for other clients. Excuse me. If you want to stay in touch, here are my contacts, LinkedIn and Instagram. Also, last year we have launched a community for women in tech, so it's called Cat Bites. This is our website, and it's going to be featured in the presentation later. Nice. So, what is on the agenda today? We're going to discuss, first of all, why it's important to make the right infrastructure decisions. Then I'm going to walk you briefly through the decision framework that I propose. It's a simplified version, just because I know we are working in Agile. We don't always have full time to go through proper software development methodologies and stuff. So this is kind of the approach I want to try for my next projects. Some steps of this framework, they include a couple of familiar steps like identifying non-functional requirements, then identifying functional requirements. But then what I propose to do is that once we have a list of features and functional requirements, we can bucket them into different categories that can then be more or less cleanly mapped to different AWS patterns. After that, we can move on to the practice. Since it's a practical decision framework, I prepared a couple of real-world use cases for us to go through together and to see how this framework works in practice. And finally, since luckily coding is also my hobby, on the weekend I built a small AI-powered tool just for this presentation. It's not deployed yet, so but I'm ready to make it into a separate open source project. If anybody wants to collab, reach out to me. Okay. So this is more of a rhetorical question, but why do we need to make the right infrastructural decisions? I listed it for just to have a logical structure of the slides. The main factors that come to mind are if we do the wrong decisions on the infrastructure initially during the planning stage of the project, we can end up with cost overruns, slow performance, security compliance issues, reliability issues, can be increased time to market if it's critical for your project, and many other factors, okay? So, the framework that I suggest today, it's weird to implement your own framework, but okay, it's just 7 steps. So the first one, as I mentioned already, it's identify non-functional requirements, something that can globally be applied to your project, to project context. We will go into more detail later. The second step is identifying functional requirements and then bucketing them into different categories that can then be mapped to AWS patterns. So this is the approach I want to try out on different projects that I'm going to be working on in the future. Step number 5, ensuring observability, is a step that we often miss in our projects, just because during the project planning phase, we usually decide on the architecture, infrastructure, all the important decisions beforehand, but then we forget to actually periodically reassess that, because infrastructures can evolve. We can have changes, some significant changes in functional, non-functional requirements, any other factors that can impact the infrastructural decisions that you took earlier, maybe before a different project stage. And that's why we're going to be talking about infrastructure evolution as well. Okay? I missed the important step there, 6, infrastructure diagram. Yeah. We're going to do that because it's a slide deck based on the practical use cases. So at this stage, let's move on to the first step, which is identifying non-functional requirements. Again, there are so many factors that you can consider before building the project during the planning stage. These are, in my opinion, the main ones that are not too many to overwhelm you during the planning phase, but also enough to kind of have information to make informed decisions. They include cost, time to market, scalability. I don't think I'm going to go into detail for each of these bullet points, or maybe I planned to, so I'm gonna. Of course, you may not have answered to all these factors at the beginning, right? It's fine, totally fine. But if you have any preference for cost model, for example, you want to pay per use, you are okay with idle billing or stuff like that. Then we have time to market. Are you building an MVP? Are you building a prototype, or it's like a full-scale project? How much time you have to ship the product, right? Scalability. How scalable your app has to be. Ops overheads. Do you have the capacity in the team, or do you actually want to manage any service? These are all the factors that you will define during this step. Flexibility, latency. Okay, I changed my mind. We'll not go into detail on each bullet point. Okay, so let's just move on. It's going to be in the demo tool anyway. Identifying features and categorizing them into buckets. So I'm pretty sure we are all familiar with standard software development methodologies. This one is just slightly adds on that. So after we identify the features for the app that we want to build, it's a good exercise just to bucket them. And these are the 6 buckets that I propose to have for this decision framework. They include the interactive UI. These are basically the features that user directly interacts with, right? So user requires immediate feedback. Then we have public APIs. If your project, your application, platform has to work with any external APIs, usually public APIs. Then we have async background jobs. So these are all the tasks that technically can also be triggered by user actions, but they don't necessarily block the user. So it's a separate bucket under async. Then we have batch jobs, very resource-consuming, long-running jobs. Public bucket is for our static content, or whatever you have in mind. It can be our single-page applications, any other assets, images, reports. And finally, I had to have a separate bucket for real-time and streaming features. Okay, why these features? Because in my opinion, and based on my experience, they then, as I said multiple times before, can be mapped to different AWS common patterns. We're not going to cover all the AWS resources today, there's so many, but just the common patterns, right? Okay, this is an example. It's not a comprehensive table, just an example of what I mean when we are saying that it's an important step to categorize your features into buckets. You can group them, so you can have an idea of, already have at this stage an idea of what kind of AWS services you're going to be using for the project. Like, for example, when we're talking about interactive UI, if you're leaning towards the serverless architecture, we can think about API gateway, Lambda, the same for public APIs. For async jobs, for background jobs, we can think about SQS, queues, about Lambdas. For batch service workloads, they can be like AWS batch, Fargate, step functions for more complicated domains, right? And so on. So that's why we have to bucket our features first, according to this simplified framework. Oh, that's it. Okay, the theoretical part is over. So now we're gonna move on to the use case reviews. As I said, it was supposed to be focused on real-world projects. I selected 2 that are not related to my job. These are kind of my side projects. The first one is called Gifty Web App, and it's in the planning phase. So the idea is to build a software as a service, B2B, B2C platform that where users can create and sell digital gift cards. So this is going to be our first use case to review, and let's now apply the decision framework to this project. I already listed, just to be more efficient, all the factors that I mentioned during non-functional requirement slides. Let's just quickly go through them together. So for this project, for example, the cost model, I am thinking about pay-per-use billing, since I'm not expecting any high traffic, at least in the beginning of the project. After post-launch, Time to market, I would like to specify here like a prototype speed, because it is sort of a side hustle. I want to build it as soon as possible. Then we have scalability needs. Here I select low, ops overhead minimal. I'm just one person, I don't want to manage any servers. Flexibility high. What do we mean by flexibility here is that I know that the scope of the project is going to be evolving. I want to be able to build it in a way that it's going to be highly flexible. So I can add features, swap features, as my product matures, right? Then there is latency profile. I selected medium. Again, you might not even have all the answers for all these comparison factors at this step. Or some of these can even be applied to features, to individual features. But for this step, I would say medium latency is fine. Cold starts are okay with me. Basic compliance level, evolving scope, as I mentioned, it's just an MVP at this point that I'm planning, but it's going to be evolving and there are going to be new features. And if you're going to have also a database layer, it's just not super critical, but it's a good idea just to ballpark the data volume. In this case, it's going to be low data volume for the beginning of the project after it goes live. And the availability options, I would say basic. It's not a critical system, so nothing super important there. I would say basic. And traffic pattern, I selected spiky, just because I think it's going to be more or less steady, with the exception of probably holiday seasons, when people are buying a lot of gift cards. I don't know. This is just initial assessment, right? That's why we will be talking about infrastructure evolution, because the metrics needs to be monitored throughout the life cycle of the platform. Okay, so since we have identified the initial factors, we now can start to have in mind which architecture, AWS architecture, we would like to apply. For the majority of this, you see, it leans towards serverless architecture, maybe with the acceptance of scalability needs. But yeah, so at this point, I would say we have serverless in mind. Then step 2, functional requirements. I already listed the main features of the app. I don't have to read them. Let's just, okay, there are different features. We're gonna bucket them, right, into different categories on the next slide, since we're doing a practical exercise. Landing page tells me a static content, public content bucket. Then we have the majority of the features are going to be interactive UI, so where the user directly has to interact with the features and receive immediate feedback. But there are a couple of async background jobs there, like inviting users by email, sending gift card details to users who buy gift cards. Like, yes, these features, I would say, you just fire them and forget about them, so the user doesn't need to have an immediate feedback at these background jobs. And finally, we have one daily report on gift card sales, which can be a scheduled background job. So this is useful to keep in mind at this step. The next one is, it sounds a bit boring, huh? Okay, but now we're at the step to map the buckets to actual AWS patterns. And luckily for us, they map pretty well. Like when we're talking about static content, we immediately think about S3 and CloudFront for caching. Or when we are talking about admin account, login, we think about authentication, services like Cognito, AWS Lambda, API Gateway, and also majority of these features are going to be communicating with the database. So they're going to be, I'm going to list Aurora Serverless, since we have identified low data volumes in the previous steps, right? Okay. And for the daily report on gift card sales, I am thinking EventBridge, backed by AWS Lambda, Aurora Serverless, S3, and simple email service. So this is kind of initial thoughts that I have after I have bucketed the features into different categories. Finally, this is an optional step. Okay, this is an optional step. If you want to go into more details and you want to sketch like a more advanced diagram, you can start to think about VPCs about different AWS resources that need to go into specific subnets. You can have private, public subnets and stuff like that. So it's an optional cheat sheet. Finally, step 5, ensuring observability, as I mentioned, right? Just a few examples: CloudWatch, X-Ray, Cost Explorer. All right, okay. And finally, no, I wasn't supposed to show that. I was supposed to say like this, at this point we have enough information to start to draw our initial diagram. Ta-da! This is the diagram. I know it looks very basic, but it has all the important components, right? We have our users going to our website, we have a caching implemented, we have our website, let's say it's an X app on our S3, or we have other static assets in another bucket. Then our app is gonna be essentially serverless backend, so we're gonna be working with a bunch of Lambda functions behind an API gateway. Can I show it? Do you see the mouse? Oh yeah. So some of these Lambda functions will talk also to Meetup authentication service. Some of these, maybe majority, will be in communication with the database, and some of them are going to be delegating tasks, and I'm talking about async background jobs here, to the SQS queues, where it can be further delegated to different Lambda workers, right? And here I made a mistake. I'm sorry, it's a bit wrong. So this arrow is not supposed to be here. It's supposed to be here, from a Lambda to serverless database. Yeah, I don't think it's a big problem. So just imagine this arrow is coming from here, okay? Then a Lambda function, in turn, will be in touch with the email service to send emails for some delegated jobs. On top of that, we have a separate daily report, let's say event bridge daily here, that also triggers Lambda daily function that needs to generate a report, save it to S3, and also maybe send it by email. And it also has to, like, an arrow also has to go from here to the serverless database. Apologize for this. Nothing I can do at this point. And yeah, so that's it about case 1. I don't know how much time I have. 5 minutes. Maybe, okay, I think I can do that. This one is going to be very fast because we're not going to go through the same steps again. Here we will skip the first 2, like non-functional requirements. We'll just assume that they are the same as when we were planning the project. What we're going to do, we're just going to analyze the metrics that we are collecting now since the project went live, okay? And then we decide whether the infrastructure needs some changes or not. Okay, so this is our website. It's actually kind of cool. I hope it's still working. Yeah, this is essentially an exaggerated pet project, right? It looks like a website. It's technically a web application, so it has some integrations with Discord and stuff. And we are using this project to teach our community members how to work on the real-world projects, basically. So what can I tell you about this one that is important at this stage is that it's a simple 3-tier architecture. We have a front end deployed to EC2, and the same with the backend, and we have a database layer, relational database, RDS, on AWS, right? So let me open first the AWS console for the front end part. I'm just quickly going to show you what I mean by monitoring the metrics. So we go into CloudWatch. It's working. Okay. All metrics. I know already, but I'm not going to spoil you. We go to EC2, pre-instance metrics, but if we choose now our production front-end server, specifically, for example, CPU utilization, embarrassing, but it's very low utilization. And if we look at the data table, you can see that the average utilization is like 2.4 39%, and the maximum was 2.66. That is actually embarrassing, but again, it's a pet project. And probably here we're going to be thinking already, look, we need to do something about it. We don't need a whole web server to manage a whole web server just to serve static single-page application. Probably going to be replacing that with an S3, right? Moving on to the backend, what do we have here? Okay, here I'm going to do some spoiler. It's the same stuff. Okay, very low utilization for both EC2 and both RDS. So I will be leaning towards replacing EC2 with a bunch of lambdas and API gateway, and replacing maybe the RDS with the Aurora serverless, because with this low utilization, we are paying unnecessarily high bills for this app. Okay, thank you very much. It's not the end of the presentation, just thank you for listening to me at this point. I just lost my presentation. Okay, so done with the use case number 2. Now, I have 2 minutes, I think, for the demo, because I built this very... I know everybody is tired of AI, I wasn't expecting to build it, but here we are. I just thought to put this decision framework into practice, because honestly, AI is a good thing to kind of analyze huge amount of information and suggest you the most suitable stack for your project, for your use case. And I just put it into an app, because I like to play around with stuff. Here you may recognize the same comparison factors that we were going through during identification of non-functional requirements. Let's use the same use case, like a Gifty, that SaaS platform for digital gift cards. As we said, cost model is going to be pay per use, low scalability, maximum flexibility, cost starts are okay, it's going to be evolving scope, basic availability, prototype speed is okay, this one is okay, latency medium, no, not high, medium, basic compliance requirements, because we'll be working with payments and stuff. What is that? Data volume options, low, and traffic pattern, as I mentioned, I expect spiking. But this is at the planning phase of the project. Now the next one, where we identify the features, these are the same features that we already went through. I'm just going to drop them into buckets, and it's hard to do with one hand, but okay. So landing page goes to, can I? I'll just worry. Thank you.
Yes,
wow. This goes to interactive. Invite users by mail is an async job. This one is interactive as well. Sending gift cards is an async, and daily report also goes to async. Thank you so much. So we bucketed them. Look, you can write any additional requirements, and then you can just get AWS stack recommendation. And it's not like I connected the OpenAI API. I customized it a little, so it has some context of the decision framework. It's not just an API key. Did you process? Okay, it took 6 seconds. Wow. So it suggests software development lifecycle methodology. I don't know if it's any, software development lifecycle methodology, agile. It also suggests the architecture based on our inputs and approximate monthly costs, as well as the services, why it proposes such services. And finally, a very basic diagram. As I said, this is a work in progress. If anybody wants to collab, I have like a pretty nice roadmap for this tool. So yeah, this is the demo that I wanted to show. Also, if you, for example, don't want to go with microservices, you can just say like, our team can't use microservices architecture. And maybe it's going to update the infrastructure diagram for you. Yeah. Anyway, that's it for today, basically. I think I'm on time, yeah? Yes, thanks so much.